So this is the multiple choice problems that were on there. So the first one's asking you to figure out what the instantaneous speed is. So the instantaneous speed is not the same thing as the average speed. So the average speed is total over time total, distance total over time total. But that'll give you the average speed for this whole thing. But we can tell that this thing's accelerating because its spacing isn't even. So it is accelerating. The spacing's not even, so it's got to be accelerating, which means you can't do total distance over total time, which rules out C. Okay? You're never going to be able to use the total distance or the total time, because what we really need is the interval. So the reason B is right is it's this interval right here, and the time for each one is 0.1 seconds. So there's 0.1 seconds between that interval, which is that, and then there's 0.2 meters in that interval, which is this. So the reason B is correct is because it's that smallest thing. If you are doing pre-cal, you might have gotten to this. It's like a limit. The other way to look at it is if we had a graph of distance versus time here, the slope of the line is the velocity, or the average velocity. And so if you do a big average velocity, like from the first to the beginning, it doesn't really work. But if you narrow that section down, now that velocity is going to be much closer to the instantaneous velocity at any given point. Okay? Okay, number 2. A person walking along a straight line moves such that her velocity as a function of time can be represented in the graph above. At what time does the person have the same position as she had at time t equals 0? All right, so we need to find the area under the curve here. This is going to be our positive velocity. So we've got these 3 little sections. So we've got 2 times 2 is 4, but cut it in half because it's a triangle, so 2, plus 2 times 1, which is 2, plus 2 times 2 divided by 2, again, 2. So the distance traveled here is positive 6. So we want to figure out where this section gets below positive 6. All right? So we know it's not at t equals 5 seconds, right? Because it hadn't gone backwards yet. So we're really checking these last 3. So let's check at 8 seconds where it's at. Okay, so at 8 seconds, we've had a time of 3 seconds from 5 and a speed of -3. So if you made a mistake and did -3 times 3, that would be 9, and you would say, oh, well, it's below it. But remember that this is a triangle, so I've got to divide this by 2. And so at 8 seconds, it's gone -4.5 meters. And so it doesn't reach it during that interval. It doesn't reach it during that interval. So the answer has to be D when it's greater than 8 seconds. All right? Number 3. A toy car is initially at rest and travels in a straight line 16 meters in t seconds. Starting at t equals 0, the car has a uniform acceleration of 2 meters per second squared until it reaches a speed of 4 meters per second. The car then continues with this velocity a time t until it reaches 16 meters is what it's saying. So basically, we've got to get to 16 meters. That's our end goal. All right? But it says we accelerate for a little bit. So basically, this object's doing something like this, vt, and then it's going to go up to 4 meters per second, and then go at a constant speed. All right, so we want to figure out, we got to figure out first how far it goes in that initial time. So I'm going to do that with x equals 1/2 at squared plus v naught t, and the initial velocity is 0. X is equal to 1/2 times 2, and if it's accelerating at 2 meters per second squared, a equals v minus v naught over t. Again, that's 0. So if we're trying to find t here, so this is 2 equals 4 over t, it would take 2 seconds to reach 4 meters per second squared. Okay, so to reach the speed, so basically in this section here, all right, for this initial section, the object traveled 4 meters. Okay, so in the first 2 seconds, it traveled 4 meters. So now we need to figure out how long it's going to take to get to 16 meters. Well, now it's going 4 meters per second, which means that every second it's going to gain 4 meters. So at second 3 seconds, it's still going to be 8 meters. 4 seconds, it's going to be 12 meters. And 5 seconds, it's going to be 16 meters. So is that an answer choice? Yes. 5 seconds. M4. A student performs an experiment to determine whether an object released from rest truly exhibits free fall motion. The student takes data of distance and time. If these objects exhibit free fall motion, which of these graphs will be a straight line? Well, remember, distance and time is curved, but distance and time squared is linear, which was a terrible linear line, is linear. There we go. So it should be B, distance versus time squared. All right, 5. A car starting from rest accelerates for t seconds with a constant acceleration a, traveling a distance d and reaching a speed v. After another t seconds have passed, the car is now a distance 3d from its initial position. What did the car do during the second time interval? Well, this is like the free response problem we did earlier. So let's take a look. So again, remember that in the problem we did today, we had basically 3 options. This should be VT. There we go. We had the object going up and then coming back down, in which case, if it went a distance d here, it went a distance 2d total, because you would have d and d. All right. The other two options rather, were that the car went up and then continued on at a constant speed. Now, if this distance is d, then just think about it graphically. If this distance is d and you were doing base times height divided by 2 is equal to d, then if this is a rectangle, it's just base times height, so this would be 2d, giving you a total of 3d. Okay? So this is the answer, right? It's going to continue going at a constant speed. So the answer is B. The car ceased to accelerate and continued forward with a constant acceleration. If the car slowed until it stopped, it would be this guy. B is this guy. But what about A? A would be if it continued to go up. So if at this moment it's D, then the easy way to think about it mathematically is like this. So if this section is D, then this new section here would also be D, and then this section would be 2D. So 2D, just like over here, was 2D, but then you've got this added section right here that would be D as well, for a total of 4D. And so that's the reason it's not A. A is linked right there. Okay? I realize these are kind of complicated. You might want to watch this a couple times to get it all the way, but hopefully this helps you. And if not, just know that most of the, 90% of the problems aren't this hard on the test. This will just separate the wheat from the chaff.